We're looking at bump-up-starter.racket, and the problem here is to use the letter grade data definition below. Here it is here. And design a function that consumes a letter grade and produces the next highest letter grade. So we're going to call your function bump-up. So here's the data definition that we did before. Listen, I want to make an important point here. In these examples, we have a single data definition and a single function that goes with it. In normal programs, there tend to be many functions that consume data defined by a single data definition. So the ratio of functions to data definitions is usually pretty high. Don't think that you have to design a separate data definition for each function. In this case, there might be a function called bump up for the nice professors, and bump down for the not nice professors, and is honor roll, and all of those would all consume letter grade. There'd just be a single copy of the letter grade data definition. In fact, we'd put it in this part of the file called data definitions, and then there'd be multiple functions down here. So now let's get on with designing this function. And I'm going to do something here, which is I'm going to put a mistake in the template. And I'm doing this to show you why it is we're always careful to run templates when we do data definitions to make sure they're well formed. So I'm just going to inject that error right there, and we'll see what happens as we go on. Now try to forget it. So here we go. We're going to consume a letter grade, and we've got to produce the next highest letter grade. So we're also going to produce a letter grade. Produce next highest letter grade. Now there's an ambiguity in this problem statement, and we're going to start to have a little more ambiguity in our problem statements because remember, design is about going from ill-formed problems to well-structured solutions. And the ambiguity here is, what do we do with A? Okay, there isn't anything higher than A, so we might just put in parens, no change for A. Now we need a stub. We'll run that just to make sure everything's well formed. Now remember, because this template's commented out, we're not seeing that error there. So now let's see, here we go. Now we need examples. If you go to the How to Design Data page, and you scroll down to the part about enumerations, it basically says that you need to have at least as many tests as there are cases in the enumeration, which is what makes sense. Going back to the code, this enumeration has 3 cases, A, B, and C. It makes sense that we're going to have 3 examples. Check expect of A. Well, we just decided that was going to produce A. And now we need 2 more. I'll just copy this one and edit it because they're all going to look pretty close to the same. Let's see, there's bump up of A, there's bump up of B, and there's bump up of C. We already said that bump up of A produces A, bump up of B produces A, bump up of C produces B. That's our examples. We'll run them to make sure they're well formed. And they are, but they're all running. One's not passing, we knew that. Okay, now we need the template. So I will comment out this stub. I'll say that we use template from letter grade. I'll go up here and get this template. I'll copy it down. I'll rename it. And now, well, this is quite simple, this function. If we are bumping up an A, we get an A. If we're bumping up a B, we get a B. And if we're bumping up a B, we get an A. And if we're bumping up a C, we get a B. And now I'll run it. Oh, and I'm getting this error, L, this variable is not defined. And Racket highlights it for me. And now I have to figure out what this error is. And I see, oh yeah, this should have been LG because the parameter name is LG. So I'll put an LG there. And now you see the reason I got this error is because the error was in the template. This is why we check the well-formedness of the templates before we comment them out, is to get as many errors as possible out of them, because otherwise every time you copy the template, you get the error copied, right? It's not good to copy code with mistakes in it. Back down here, let's run this. All 3 tests pass. So in this case, because we had an enumeration, we got not only the structure of the template, but we got the structure of the examples, because for an enumeration, you should have at least 1 test for each case. In this case, it doesn't make sense to have any more than 3, but it is possible in certain cases for functions that consume more than just the enumeration to need more tests than there are a number of cases in the enumeration. We'll see examples of that in later weeks.